Hello, welcome back to the lab. Today I'm going to show off my fourth chiptune player here. This is called the Retrosynth. And this has a Cyclone 3 FPGA, some SD RAM, actually takes an SD card, and runs on 4 rechargeable AA cells, and there's a built-in battery charger. There's a button up here, so if you hold this for 2 seconds, let go, it starts up, and it's ready to go. This LED at the top shows it's green right now. That means that it's operational. If the batteries were in there, it would be solid red for charging. Hitting this button will reset it in case it crashes, but I have never actually had it crash once it was all debugged. So on the end here they have a headphone jack, that's stereo 1/8 inch, 2 1/4 inch audio jacks for that line out, a MIDI port. On the side there's an SD card, USB. Back has power, the LED, and the button. And on the bottom, it takes 4 AA cells, and then there's a little thermistor that senses the battery temperature, so it can do a quick charge and it knows when to terminate the charge. I built this plastic stand here out of acrylic that is specifically for this. There's holes for those audio jacks. There's little recess dents for the rubber feet here. And then the back is adjustable. It moves up and down, and there's little rubber feet on the bottom. And all this was, it was a scrap piece of acrylic, and I just heated it up with a heat gun and bent it. And that's basically it. It didn't take very long. It took me about 10 minutes to make it. And this gets it up off the table, so when I want to use it, it makes life really easy. On the front here, there is a capacitive keypad here. There's no actual physical buttons. This is like a slider wheel. There's a button in the middle and 6 more buttons around the outside here. So I'll turn it on. You have to hold this 2 seconds. And it's ready to go. So what I can do, the first thing I can do is hit the middle button and it goes into the directory. And then I can just move this around in a circle and it will go through the various files in there. If you hit menu, it comes back out, and then there's actual menu. And there's like settings and other such things in there. Use the thing to go through it. You can get back out of the menu. These 2 buttons don't really do a whole lot. This one plays, stops, and then the visualizer. There's no tunes loaded right now, so I'll load something here. So I'll go load something in this directory here. I just hit the enter button and it loads it, and then I hit the play button. Simple as that. And then on these I can just tap a direction to go to the next tune in the list, or the previous one for that matter. If I want to go back to that file menu, I can just hit the button and then I can scroll through these while it plays if I want to select another one here. This one has visualizers also. I will zoom the camera in on that. There, we're all zoomed in. So now I will show off the visualizer by hitting that button. So the first one shows us similar to the SID-Man here. It's very, very similar, only this time it shows all 3 channels at once in their little bars. So F is frequency. There's a high and a low frequency bar, so it's kind of like a 2-digit bar, and then the duty cycle is the same. Then the ADSR settings, and if the channel is reversed, that means it's being filtered. Then at the top up here is in this case it's a pulse waveform, N is noise, T is triangle, and so on. And then over on the very right is the filter. C is the cutoff frequency, R R is a resonance, V is the volume, and the little L means this is a low-pass filter. And the L and R buttons still do work here. So that one had ring modulation and was filtering it too. So then I can hit the visualization button again, and now it will actually show what notes are being played. And it shows that number on the right's the octave, and this is a PAL note table, but the notes don't look like they're centered very well, so this may actually be an NTSC table, so I can change it. It's still not quite right either. And if I hit visualization again, it actually shows the memory. Each bit of the, or each pixel of the screen is 1 bit of memory, and this is showing 256 bytes of memory from 00 to FF in the corner, and this is page 10, so this would be 1000 hex to 1 FF hex. And by using the wheel, I can actually change the page. If I go enough here, I'll probably find the, yeah, there's the variables for that song. They're at 1800 somewhere. 1830 hex or thereabouts. Then hitting the button again just gets back out. So that's SID playing. This will play many other things besides SID. This also will play SAP files, which is Atari 8-bit, and that is the Pokey chip. This one has a visualizer also, but it's kind of broken. For some reason, the visualizer hookups on the FPGA were not fixed up when I converted this project, so the visualizer doesn't do anything, unfortunately. And then this one also has the same memory viewer doodad. If I look down at page 1, I'm sure I can see the, yeah, stack doesn't look like it's doing a whole lot. I'm not sure where this music loads its variables at. Yes, it also plays NSFs. And there's a lot of visualizers for NSF. There's a VRC7 visualizer, N106 or N163. There is FME7, MMC5, VRC6, and then the regular audio channels. And in this one, it's frequency, which is a dual bar again. And then we got the length counter, volume, sweep, and other things like that. Up at the top, it's showing the duty cycle. That little square wave symbol will change width depending on the duty cycle. And if the channel is reverse video, that means it's off. And then this very last one is the DPCM, which is not used on this particular NSF. So that one's using some DPCM. Then hitting it again, that would be FDS, and that shows the FDS waveform itself. Hitting it again shows the memory, and then again brings you back around. And yes, it also plays Game Boy also. This one has its own visualizer. This shows the custom waveform here. Then channel 1 square, channel 2 square. That's the custom waveform, channel 3, and then the noise channel. And L and R is showing over here which output it's coming out of, and then the square wave duty cycle yet again like before. Frequency, volume, length, and sweep, and then frequency, volume, length, frequency, volume, length. And on On this one, a inverse channel means it's actually playing, and an uninverse means it's off, which is kind of backwards from the last one. I probably should fix that. Hitting it again gives us our RAM view, so this tune uses some of the Page FF RAM. Oh, actually those are the registers. That's ColecoVision from the game Jukebox. Plays Game Gear music. So this is Game Gear music, and it'll also play Master System stuff too. So there's Master System. This will also play FM music. This is Opal 2. This is the Creative Labs Sound Blaster demo track, I believe. Visualizer for this is just RAM, unfortunately. There's nothing else. Good old Star FM. If you had a Sound Blaster card, you probably know this tune well. It came with the install disc. Don't worry, I'll play plenty of example tunes from all of these systems in this video and probably another video or two to keep the time down on each video. This also plays JCH's custom FM music format, the D00 format. Also plays raw ad-lib files. These were captured through, I think, DOSBox. Not 100% sure on that, but it'll play those too. That's a good Rob Hubbard tune when he was doing FM music on the PC, believe it or not. Plays Ken's Labyrinth music also. So that's about 5 or 6 FM formats. The Sega Master System Game Gear Coleco format, NSFs, SID files, SAP files, and Game Boy music. That's all I added to it. There's probably room to add a few more, but that's all it has right now. So that's a quick look at the workings of it, how it works, what it looks like, how the software functions and all that. Don't worry, in this and future videos I will post a bunch of chip tunes played through all these different systems on their own so you can get a good understanding of what it sounds like. But before that, now it's time to tear it apart and see what makes it tick. Before we get started on the main attraction here, I thought I would show off this little perf board here. What this is a test for the SID filters. Since the SID filters are fairly finicky, I thought I'd make this little test board here, and what this is a perf board version of the SID filter. As you can see, there has been a lot of fixes and changes to it as I worked and developed the circuit. Basically what it is, there's some 4 LEDs that show what kind of modes, low pass, high pass, band pass, a few other minor things, if the filter's on or off, what channels are going through it. There's op amps all over the place, the caps, some FETs, bunch of 4094 shift registers, some level translators, because this board actually runs at 12 volts, and the FPGA runs at 3.3 IO, so that's some level translation. This is basically a recreation of the SID filter from the bottom up. It's pretty much an exact clone of the hardware on the SID chip itself, and as such it sounds fairly close. It's about as close as I could get it for now. If I worked on it some more, it'd probably sound a little better, but when I play the example tunes, you'll be able to hear exactly what it sounds like. So here it is. I've taken the screws out of the bottom. Top comes off. And then in the top is, this unplugs. This is the signal power cable for the capacitive buttons. And interestingly enough, the data sheet kind of lied. It says it was good to go through like a centimeter worth of plastic and still function. Nope, that's not right. This is like 2 millimeters thick, and it was just way too thick. So I ended up actually, the circuit board is underneath this label, and then I connected it up with very fine wires along the edge here to the pads on the board. This is another one of those same circuit boards, and I've cut the rest of the circuit board out and then just hooked up some fine wires between the two boards to connect them. There's a little PIC on here and the little capacitive chip, and then programming header, which isn't used now, and then connection back to the main system. In the bottom here we have the display up here, which is easily removable. I'll remove that in a minute. Connection for the power here, and this is a power and the battery holder. Here we've got the LED, and then this is from that top board. So unlike some of my other ones, this one's vastly reduced the number of wires inside because now it's using circuit boards. So I'll take this display off first, and then I'll free up some room in here, and I'll unplug these cables. There is a display. This display had white characters on a blue background, and unfortunately those white LEDs kind of died over the years, and it got so dim it wasn't useful anymore. So I replaced the LEDs in this backlight with those orange ones, and that's why the display is like a nice striking orange. I think the orange looks a lot better than the white on blue ever did, so I really like that. It looks kind of like an old school neon plasma display. So now there's basically two circuit boards in here. There's this top board, which is the power supply, and this power supply is also the battery charger. This does all power management. So I'll unplug the cable here, and what's funny about this LED here on this cable plugs into here, and this is the programming port for this PIC that does the charging. So when you unplug this programmer, you plug the LED in where it was, and it uses the two programming IOs to run the LED. Here, I got a good close-up on the power supply board here. So over here is where that LED was plugged in. There's this PIC here. This PIC is doing the charger and power control. So the power button runs into here. The temperature sensors for the battery. Here's a ambient air temperature sensor here. It's a little thermistor. There's another one on the battery. Then this is a boost regulator for and this is the USB power. So when the USB power comes in, it's boosted up to about 9 volts with the circuit here. And this can slowly charge the battery, or it can run the system, but it can't do both. Over here we got a 5 volt SEPIC regulator, a 12 volt SEPIC regulator, some LC filtering, and there are no electrolytic caps on this board. There's no tantalums and no electrolytics. Then the power and the battery holder connect here. Battery charger is this inductor and this linear technology chip. Yeah, there's like quite a few fixes on this board here, as you can see. And this battery charger over here is pretty nice. It's actually a fast charger. And the way it works is it senses the ambient temperature and then the battery temperature, it compares them and figures out the rate of change. And then that's how it knows how hot the battery is getting, so it knows how full it is. And it also checks the voltage and the current and a few other things. On the bottom of the board, there's really not a whole lot. Just the power connectors. Power connector for the USB power. This is the reset, and then the actual 5 and 12 volts that runs the unit. Then this connects to the button and the thermistor and a few other minor things. So that does it for the power supply. Here you can see the main guts. I got a SD card and holder here at the top, and 16 megabyte SD RAM. There's the flash ROM that holds the FPGA configuration data. Then there's the Cyclone 3 here. There's a little oscillator, the 2 1/4 inch jacks, headphone jack, and then a dual buck regulator. This is generating 3.3 and 1.2 to run the FPGA and friends. And then underneath here is all the analog, and I'll take this board out and flip it over here in a minute. And then that's pretty much it. Up here is a pot to change the contrast on the LCD, and that is pretty much it. There's nothing else up here. The circuit board is just kind of blank. Bottom of the case is pretty much empty. Did some fixes with some Bondo right here and some epoxy putty before I painted it. Yeah, there's the board outside of the enclosure, the top side, and then the fun part where all the fun happens. The bottom here is where all the fun happens. Since this is a 2-layer board, FPGA power and ground is very important, so I made like these rings, so that's 1.2 volts ground and 3.3 volts on the outside. And then I tried to reduce the impedance a lot that way. And then down here we got a PIC that's doing the USB, a level translator between the PIC and the FPGA. And then we got our analog filter circuitry is taking up most of this room. There's a 8-channel analog switch, some op amps, a whole bunch of other fun parts are under there. And then over here we got a quad digital resistor, so that's doing volume control, some of the filtering stuff. And then we got the amplifier, headphone amp, and then there's a whole bunch of fixes on the analog here. Let's see if I can zoom in on that. So that's a good zoom in on that. See some of the chips in there. There's like that 074 op amp, a 324 op amp, another 324. There's the PIC with a really cool clear crystal there, a 20 megahertz crystal that's like clear. There's that level translator. Bottom detail on the FPGA. Little chip there's a 2.5 volt regulator. And that's pretty much it for the bottom. Show the top again here, so you can get a good close-up of that. So that's the main guts right there. The FPGA and that SD-RAM do most of the work. There's that power supply up there. So another detail, and that's pretty much what's in there. And then this black connector, of course, is a display connector. Close up of the display, I have this long header arrangement on there to get the signals from the display down to the circuit board. And it's just a really basic LCD. I got this from Crystal Fonts. If I was doing it again today, I'd get it from eBay, since this is just a commodity display. There's my fix there. I had to use some fine wires to hook that back up after I took that little white part out. That white part's a very tiny circuit board with two extremely tiny 0402 sized LEDs on the other side of it. Well, that about does it for the hardware and what's inside. Next, I will go through and play a bunch of example tunes on the various cores and run it through the sound card again like on the other video, so you can hear exactly what it sounds like. I hope you enjoy it, and thanks for watching.